All right, I need everybody back in their assigned seats quickly. We gotta go. We gotta roll. Come on. Page 4. Allison, seat quickly. Get where you're supposed to be. All right, we have to write any mixed number as improper fractions. Add and subtract the numerators and keep the common denominator. So, if we need to review, remember to change to improper fractions. We had to multiply the denominator with the whole number. So we completed like a whole circle and then added the numerator, and then we kept the denominator the same. So that is what we have to start with on some of these. Some of these we don't have to do at all. But page 4 says adding and subtracting fractions. Come on, guys, what's going on? These are something I told you to get at the beginning of the hour. All right, 7th graders. These are already fractions. They're not mixed numbers, so we can skip step 1. We can move on to step 2. Yep, I can adjust it a little bit. I can't right this second. Okay. It should be right in the top of your Google Classroom because I sent a thing to you. Otherwise, look for the quizzes way back when. Okay. Open it up, Samantha, and I can show you. Open it up and get it ready so that you're there, and then I'll show you. All right. So we're adding the numerators. What's 7 plus 3? 10. The only reason we can add that is because our denominators are the same. Keaton, move. Our denominator is going to stay the same. Mm-hmm. Can we simplify this? Yes. What could we divide both 10 and 20 by? We could divide them by 2. We could also divide them by 5. We could also divide them by 10. You could cancel out your zeros. That's the same as dividing by 10. 1/2 is 1/2, right? All right, so our denominators are the same. So we're looking at 13 minus 1, which is what? 12/16. How can we simplify that? I could divide by 2. I could also divide by 4. I cannot divide by 6. So 4. 3/4. All right, we could skip step 1 for numbers 1 and 2 because we didn't have any mixed numbers, but now we have a mixed number, so we have to change it to an improper fraction. What's 3 times 10 or 10 times 3? 30 plus this 1 is what? So 31/10. I have to rewrite it, and then I'm bringing down the rest of the problem. Minus 7/10. No. We changed it to an improper fraction.
24/10.
24 over 10. Do you want to simplify first or change to a mixed number first? Change to a mixed number first. So how many times can 10 go into 24? 2, which is 20 times, right? So 4/10. What can I divide 4 and 10 by? 2. So I have 2 and 2/5. Did that take a lot of steps? Yes, it certainly did. Should we be showing all those steps and not just the answer? Yes, we certainly should. All right, we have 2 mixed numbers to change now. So we're going to say 12 times 5, which is 60 plus 1 to 61/12. And then we have 12 times 1. 12 plus 7 is 19.
Over 12.
Hold on. We have to add now. 6, good. 80 over 12. What can I divide them both by? Does 6 go into 80? No, 6 won't go into 80. But, oh, do you want to divide by 12 first? We could. Okay, so if I'm dividing by 12 to change into a mixed number, how many groups of 12 can I take out? 6 is 72. Is that what you're saying? So 6 whole groups is 6 times 12, which is 72. 80 minus 72 is 8. Now we can divide them both by 4. So I still have 6 and 2 over 3. All right. Changing to improper fractions. 8 times 1 is 8 plus 7. So 15/8 plus, what's 8 times 3? 24 plus 3. 27/8. 5 and 7 is 12. 42/8. So how many groups of 8 can I take out? 5 whole groups would be 40, right? So I only have 2 out of the 8 remaining. What? 4? Can I divide 2 by 4?
Yeah. Oh, I'm behind stuff. Sorry about that.
I was like, wait, what? We can't divide 42 by 4 either. If that's what you were thinking. If you were back at this step here, we can't divide 42 by 4. All right. So now we have 2 8s. What can I divide them both by? 2. 2 divided by itself is 1. 8 divided by 2 is 4. All right. Our first step is to change to an improper fraction. So 4 times 6. 24 plus 1. So 25 over 4 minus 4 times 2. 8 plus 3. So then we're looking at our numerators. 25 minus 11. How many groups of 4 can I take out of 14? Which is 12, right?
Yes.
Which is 2/4.
Or half.
Or 1/2. So if I divide them both by 2, I have 3 1/2. We should know how to go step by step by step by step. All right, here's some applications. One cat weighs this much, another cat weighs this much. Find their combined weights. Can we do this one a little differently? If we're adding them, if we have 12 5/9 plus 16 7/9, can we first add the 12 and the 16? Would that make sense? 28, right? Which means we have 5/9 plus 7/9, which is what? 12/9. So how many groups of 9 could I take out? One and 3/9, because this is 9. Now I have 1 1/3, but what do I need to add back to it? The 28. So 29 1/3. You could say 9 times 12 plus 5, 9 times 16 plus 7, and then add them together, but then you have this big astronomical number. So but it is especially important to change them into improper when we're subtracting. Okay, so we can't do the same thing here. We have to say 3 1/15 inches minus 2 7/15 inches, because we're wanting to know how many more inches did it rain in May than April. So May minus April. Yep. We're trying to figure out difference in rain. So what's 15 times 3? 45 plus 1. 46/15 minus, what's 15 times 2? 30 plus 7 is 37/15. So this becomes 46 minus 37. Well, 46 minus 36 would be 10. So 1 less than that is 9. Excuse me. Sorry. So 9/15. What can I divide them both by? 3. So 3 over 5. All right. So before we move on to adding and subtracting with like, oh, I guess that's it. Okay, not for today though. That's it on like denominators. Now we have to deal with unlike denominators. So all we had to worry about here were our numerators, because our denominator was the same. So before we can do these next problems, we have to make our denominators the same. Yes. So we're looking at least common multiples. We want these to match. So if you look at your 12 and your 4, shoot. Somebody took my planner. Oh, nope, it's right here. If you look across your 4, you notice 12 is a multiple of 4. So we can keep this first one the same. It's 13/12. But what do I have to multiply the 4 by to make 12? 2 would be 8, but 3 would be 12. So if I multiply the bottom by 3, what do I have to do to the top? Yes, whatever I do to the top or whatever I do to the bottom, I have to do to the bottom or the top. So I've got to do the same thing to the top and the bottom, because that's like multiplying by 1. We know anything multiplied by 1 keeps its identity. So what's 3 times 3? 9. So now now my denominators match. So now you can do this problem. Try it. You're going to have to turn it into a mixed number, right? All right. So you got what here? 22 out of 12. How many groups of 12 can come out? One whole group? Keaton, I need you to stop or go. So 22 minus 12 is what? 10. I can simplify this. What can I divide them both by? 2. So 1 and 5, 6. Right? 10 divided by 2 is 5. 12 divided by 2 is 6. Okay. Yikes. All right. Looking at 4 and 8. Again, when we look at our 4, we see that 8 is a multiple of 4. So we can leave this second one the same, but we need to change this first one. So what do I multiply the 4 by? 2. So whatever I multiply the bottom by, I have to multiply the top by. So 2 times 9 is 18. 2 times 4 is 'Now you should be able to do this. And again, you've got an improper fraction that you have to change to a mixed number. All right, guys. So 18 minus 5 is 13. Then you took one group of 8 out. 13 minus 8 is 5, and you write it over the denominator. Okay, this gets a little tricky. We have to look at the multiples of 6 and the multiples of 4. So as I look across the multiples of 4, I see 4, 8, 12, 16, 20, 24. As I look down the multiples, I see 6, 12, and I notice right away they both have a 12. So I want to turn them both into 12. So I have something over 12 plus something over 12. Well, how do I change that 6 to a 12? Multiply it by 2. Whatever I do to the bottom, I have to do to the top. So what's 2 times 13? 26. All right, what do I multiply the 4 by to change it to 12? 3. So 4 times 3 was 12. Whatever I do to the bottom, I have to do to the top. What's 15 times 3? 45. So this becomes a great big number. We have to add 26 and 45. Well, 6 and 5 makes 11. Carry the 1. 5 plus 2 is 7. Did you get 71? 71 twelfths. So this is almost 6 wholes, right? Because 6 wholes would make 72. So it's not quite 6. So it's got to be 5. 5 groups of 12 is 60. So I have 5 and 11 twelfths remaining. Okay, now I'm looking at 4s and 7s. So I'm following my 4s, 4, 8, 12, 16, 20, 24, 28. And then I'm looking at my 7s and I notice there's nothing less than 4 times 7, which is 28. So my new denominator has to be 28. So something over 28 minus something over 28. What do I multiply the 4 by to make 28? 7. So 7 times 7 is what? 49. What do I multiply by 7 to make 28? 4. Whatever I multiply the bottom by, I have to multiply the top by. What's 3 times 4? So now I can do this because my denominators are the same. Before, I couldn't do anything because my denominators were different. 9 minus 2 is 7. 4 minus 1 is 3. How many groups of 28 could I take out? Just one. One group of 28 is just 28. Is that 9? 9 28s? All right. Well, how would I write 2 as a fraction? Do you remember? How would I write 2 as a fraction? 2, not 2 over 0. That would be undivided. 2 over 1. So I want this 1 to be the same as this. What would I have to do to the 1 to make it 5? So I'm going to multiply the bottom times 5 and the top times 5. What's 5 times 2? 10, and 5 times 1 we just said was 5. Do I need to do anything to this? I've just made this out of 5, so I can keep it the same. Can you do this? You can do this. What's 10 minus 1? 9. I have a question. Yes. So you take out one whole group of 5, then you have 4 remaining out of that 5. Out of that 9, right? I should say. All right. What would be my least common multiple? Well, look at my 6s. 6, 12, 18, 24. Look at my 2s. 2, 4, 6. Could I make them into 6s? So I don't need to do anything to the one that's already out of 6. I'm keeping that the same. What do I need to do to 2 to make it a 6?
Wait, what?
How do I make the 2 a 6? So if I multiply the bottom by 3, I have to multiply the top by 3. So I have 9/6. What's 41 plus 9? How many groups of 6 can I take out of 50? 8, because 8 times 6 is what? 48. Uh-oh, we're not done. 2 over 6. We can't stop here this time because we have to divide them both by 2.
1 over 3.
No, it's, oh yes, 8 and 1/3. When you said 1 over 3, I got confused. Hurting your brain. All right, now I have a 9 and a 6. A 9 and a 6. I need to find something they have in common. Looking at my 9s, guys, I have 9, 18, 27. Looking at my 6s, I have 6, 12, 18. I notice they both have 18 in common. So I'm making this, I'm going to go way down at the bottom, something out of 18. Something out of 18. Can we do the same thing we did before? Can we say 1 plus 4 is 5? So then we don't have huge numbers. What do I have to multiply the 9 by to get 18? 2? So times 2 times 2. So 10 18ths plus, I have to multiply these by 3. So 5 and 25 18ths. How many groups of 18 can I take out? 1. So that makes 6. And what? What's 25 minus 18? And 7 18ths. All right, this one we do need to change first. 12 times 4 is what? 48. 48 plus 11 is 59 twelfths. Minus 5 ninths. Sorry. 9 and 12. It definitely helps to know your multiplication facts, right? 12, 24, 36. I know 36, 3 and 6 add to 9, so that's a multiple of 9. So 36 is what we're taking out. We're changing them to, rather. So we're multiplying by 3 by 3. I would definitely use your calculator. By 4 by 4. What is 3 times 59? 177. Nice. Nice distributive property there.
I just take away the 9 and then add the 9 up. And then add after.
All right, 177 minus 20 is 157. This is one that you won't see much of. Divide that by 36. I would say 157 in your calculator divided by 36. See what whole number you get. 4. So 4 times this. 4 times 36. What's 4 times 36? 144. So 1336, is that right? I'm not sure. Tomorrow, we are going to continue notes on that. We're gonna have lots of practice on unlike fractions.